Welcome everyone to BTT 151, Fundamentals of Electricity. Let's take a look at Unit 2 on electrical quantities. So some terms you're going to see defined in your text this week. Coulomb, the unit of charge, represented by the capital letter C. Pretty big value. Those negatively charged particles, the electrons that we spoke of last week, 6.25 times 10 to the 18th electrons would define 1 coulomb of charge. So just to give you an idea of how large of a number that is, add 16 zeros after the 5 and 6.25, extend that out 18 places, so very large number. Electrons in motion we refer to as current flow. So traditionally the ampere for a DC electrical circuit is represented by the capital letter I. And formal definition of an ampere is movement of charge past a given point in 1 second. Voltage in a DC electrical circuit represented by the capital letter V. I've also listed here the schematic symbol for a battery that has positive and negative polarity. So the formal definition of voltage is the difference of potential between 2 points in an electrical circuit. And as you're going to see, this is going to become very practical. When you measure voltage in lab with your digital multimeter, your 2 test probes, you're always going to measure voltage in 2 separate locations. And then lastly, resistance, which is defined as the opposition to current flow in a DC electrical circuit, represented by the capital letter R. And you will always see the small Greek letter omega as it applies to resistors. So I've listed here also the schematic symbol for a fixed resistor. The expression that ties all of these terms together is called Ohm's law. And what Ohm's law does, it takes a look at the relationship between the voltage V, the current I, and the resistance R. So the traditional algebraic expressions for Ohm's law, voltage V is equal to current I multiplied by resistance R. Current I is equal to voltage V divided by resistance R. And resistance R is equal to voltage V divided by the current I. So the original base equation, you can algebraically manipulate that to get the other 2 values. So Ohm's law we're going to use quite a bit. Very, very useful when we do circuit calculations. So you are going to have some circuit calculations in your homework this week's assignment. What you're going to find, you're always going to be given 2 of the variables, and then you're going to be asked to solve for the third. A complete circuit. For a circuit to be considered a complete circuit, I need 3 components. I need a voltage source, I need a continuous path of current flow, and I need some load. So in a DC electrical circuit, we identify the voltage source with our schematic symbol for a battery, identified by the capital letter V. Notice I have a direction of current flow, identified by a capital letter I for current, and then I have some load. In this case, I'm inserting a fixed resistor in the circuit. So we call this a complete circuit. When you do circuit analysis, 2 approaches, let me call it, that we can use. One is called conventional current flow, and the other is called electron flow. Each of them work exactly the same, but you're going to find it's just going to be a difference in polarity. In conventional current flow, what we do, we assume current leaves the positive post of the battery, flows through the circuit, flows through the load, and then returns to the negative post of the battery. Electron flow, just the opposite. In electron flow, we assume current leaves the negative post of the battery, flows through the load, and then returns back to the positive post of the battery. I've used conventional current flow, part of my training going way back. Either method is fine. Where we really got into electron flow with the semiconductor industry, we know that an electron is a negatively charged particle, of course. So it is more intuitive to say that a negatively charged particle is going to leave the minus post of the battery, negative post of the battery, go through the load, and return back to the positive post of the battery. All right? Should also mention what you're going to find in your text. It's called an Ohm's law wheel or an Ohm's law triangle where we can set something up that looks like this. So if you were to get mixed up a little bit on the algebra, you can use the Ohm's law wheel. And how we use the Ohm's law wheel, for example, if you want to solve for voltage V, simply cover that variable. So V is going to be equal to current I multiplied by resistance R. If you want to solve for the current I, simply cover that variable. So I is going to be equal to voltage V divided by resistance R. And then lastly, if you wanted to solve for the resistance R, again, same approach, simply cover that variable. So resistance R is going to be equal to voltage V divided by current I. So please take a look at Unit 2 in your text. There's going to be a PowerPoint presentation to accompany your reading in the text. And I've also uploaded a video presentation on Ohm's law and how voltage, current, and resistance relate to each other. And it's produced by what's called the Engineering Mindset. We're going to use several of these during the course of our semester. Lots of good information. So again, please read the text, take a look at the PowerPoint, review the video, and then follow up with the homework assignment. Have a great week, and we will see you next week. Thank you.